Okay, we've already looked at binary shifting, so how is arithmetic shifting different? Well, arithmetic shifting is if we need to divide negative numbers. So logical shifting is multiplication or division of positive binary numbers. We use arithmetic shifting if the binary number is negative. So this is a 2's complement with a signed integer negative binary number. Can you work out what that number is as a denary number? Pause the video now and calculate this value as a denary number. Okay, so hopefully you came up with the denary value of minus 20 because this is the most significant bit. We're in the left hand bit here, so minus 128 plus 64 is minus 64 plus 32 is minus 32, minus 32 plus 8 is minus 24, plus 4 equals minus 20. So this is a negative number equivalent to the value of denary minus 20, and we are now going to shift right. We're going to divide by 2. So to divide by 2 we want to shift right once. So let's do that. So this one gets shifted to the right, so we put this one here, this one goes here, this one goes here, this 0 goes here, this one goes here, this one goes here, this 0 goes here, and this 0 just gets lost off the end here. Okay, so loss of accuracy as we've discussed before. So is that it? What do we do with this left hand here? Do we put a 0 here? Do we put a 1 here? Well, with arithmetic shifting you do this weird thing where you go diagonally, you move this 1 diagonally, but you also basically drop it vertically as well. So you always do this with arithmetic shifting. This one drops down vertically and also gets shifted to the right. So we've already said that this value is equivalent to minus 20. So minus 20 divided by 2 in denary is of course minus 10. So is this number minus 10? Let's check and see. Pause the video and calculate this negative binary number to see if it is minus 10. So hopefully you did your calculations and it came out something like this. So we've got a remember we are calculating what this number is. So if we are, so it's minus 128 plus 64 plus 32 and plus 16 as well. So that gets us to minus 16. This one here has a 0, so we're not adding this one. This one here has a 1, so we need to add 4. So minus 16 add 4 gets us to minus 12. And this one here means we have to add 2, which gets us to minus 10. Yay! I didn't make a mistake on YouTube. How wonderful. So we have right shifted once, which is equivalent to divided by 2, and with arithmetic shifting remember that you drop down vertically as well as shifting to the right. Okay, let's do another one. Now this time we're going to use the same number that we used last time, so that is equivalent to minus 20. Okay, so denary minus 20, but this time we're going to right shift twice, and a right shift twice is dividing by 4. So right shift once is dividing by 2, right shift twice is dividing by 4. If we were to right shift 3 times it would be dividing by 8. Now we're going to right shift twice, dividing by 4, so we drop this one down vertically and we also drop it across 2 spaces. Okay, so that one goes here, which means that this one goes 2 spaces, so that goes here. This one goes 2 spaces, so that goes here. This one goes 2 spaces, so that goes here. and so on. So we've got a 1, this one goes here, and this one goes here. Okay, and these two zeros drop off the end. But what do we do here? Okay, we've got a gap here because we've dropped down vertically and we've shifted right 2 places. So what do we do here? It's really important to remember that you don't pad with zeros, you put a 1 in here, okay, because it is arithmetic shifting. So remember that, really important. If you're shifting twice or more, you pad the gaps with a 1. Okay, so pause the video, let's work out this number. Is this number that we've created here equivalent to the -5 that we should be getting? And hopefully in your calculations you got something like this. Remember, this is the number that we are working out. So we've got a 1 here, so that means that all of these figures are going to be 128 plus 64 plus 32 plus 16 plus 8 as well, brings us to -8. Okay, then we've got a 0 here, so we don't do this 4, but we have a 1 here, so we do use this 2, so -8 plus 2 is -6, and then we have a 1 here, so we -6 plus 1 is -5. Okay, so good work. Hopefully you achieved the same output I did. Obviously, if you put a 0 here, you're going to get a completely nonsense result that doesn't make any sense at all. So remember, when you are padding out, that you have to put a 1 in the gap. Okay, so we've got a new binary value here. It's a negative binary number. So we need to use arithmetic shifting, and we want to divide by 2. So that means we shift once. Okay, so can you take this number, shift once to the right, and then work out what the new number is? I'll pause the video now, have a go at it, and then we'll work through it. Okay, so hopefully you have been able to do that. So obviously we're arithmetic shifting, dividing by 2 means that we shift once to the right. Okay, so we're going to drop this one down vertically, 1. We're also going to shift once this number once to the right, which means this number goes there, this number goes there, this number goes there, this 0 goes here, this 0 goes here, this one goes here, and this one just disappears off the end. So now let's work out if we are correct. And a way we can do that is if we work out what this number is first, and then as a denary number, and then if we work out what this number is as a denary number. So let's work out what this number is as a denary number first. Okay, so we've got a 1 here, so 128 minus 128 plus 64 plus 32 plus 16. Well, that gets us to minus 16. Okay, there is a 0 here, so we don't add the 8. There is a 0 here, so we don't add the 4. There is a 1 here, so we do add the 2. So minus 16 plus 2 equals minus 14. And there's no more addition to do because there's a 0 here. Okay, so we know that this top number is equivalent to the denary minus 14. And what if we divide minus 14 by 2, we should get minus 7. So is this number equivalent to minus 7? Let's find out. So we've got a 1 here, so that means we start at minus 128 plus 64 plus 32 plus 16 plus 8. So that means we are now at minus 8, because minus 128 plus 64 gives us minus 64, plus 32 gives us minus 32, plus 16 gets us to minus 16, plus 8 gets us to minus 8. Now there is a 0 here, so we don't add that one, and then there is a 0 here, so we don't add that one, but there is a 1 here, so we do add to that one. So minus 8 plus 1 equals minus 7, which is good news because that's what we are looking for. Okay, let's do another one. So I wonder what happens if we try and divide a odd binary, negative binary number. So this is the minus 7 that we worked out a minute ago, expressed as a 2's complement negative binary number with a most significant bit. No surprises so far. So what happens if we try and divide minus 7 by 2 using arithmetic shifting? So if we want to divide by 2, we are shifting once. Okay, I think you probably know that by now. So let's pause the video, and if you shift once to the right to work out what this binary number is, you have to use arithmetic shifting and show you're working. Have a go and we'll go through it in a sec. Okay, so hopefully you have remembered by now that with arithmetic shifting to the right, you take this most significant bit and you drop it down vertically, but you also shift once to the right. So basically by now I'm hoping that you realize that we are basically moving everything across 1, and this one drops off the end. Okay, so what is this number as a denary number?
Okay, so minus 128 plus 64 plus 32 plus 16 plus 8 plus 4
gives us a value of minus 4. So in this example, we've got minus 7 divided by 2 is not 3.5, it is minus 4, because we have this loss of accuracy when we have numbers dropping off the end here. Let's do another one. Okay, so this is the 2's complement binary number with a most significant bit, and it is equivalent to the denary value minus 36. And we are going to divide by 4, which is what we need to do then. Yes, you guessed it, we need to shift twice. Okay, so let's do that. So we drop down vertically, as we always do, but we also jump across twice. So from its first position, jumping across to the second position there. So this one is now here, this 0 is now here, this one is now 2 spaces to the right, and we keep on going, and then these last 2 zeros, they've dropped off the end, so they have disappeared into the ether. So at the beginning, obviously we drop down vertically. So what goes in this gap? Do you remember what we pad out with? Yes, it is a 1. Very important to remember that it should be a 1 and not a 0. So let's check this. Is this the correct value? What is minus 36 divided by 4? Well, what we should get is minus 9. So is this number the 2's complement binary equivalent for the negative number minus 9?
Okay, so we're starting with minus 128 plus 64 plus 32 plus 16, so that gives us minus 16.
And then we want to add 4 because there is a 1 here, so minus 16 plus 4 equals minus 12, and we have a 1 here, so we need to add 2, so that gets us to minus 10. And then we've got a 1 here, so we have to add 1 as well, which gets us to minus 9. So that is the correct answer. Okay, let's do one more, but just bringing in a couple of previous learning points. So can you work out using 2's complement what minus 68 should be, and as a 2's complement negative binary number, and we need to put that into there. So pause the video and see if you can remember how to do that. To do this, we use 2's complement. So to use 2's complement, we put the positive for 68. So we'll put the positive on this row. Then we flip, and then we add 1. So I'm pausing again just in case you needed that hint to make it work. And then in a few seconds we'll give you the answer, which you probably already know. Okay, let's do it. So what is the positive binary value for 68? So it'll be 0, so that's 64. So we just need to add 4 to that, so that goes there. And then we flip everything. So 0 here becomes a 1, 0 above here becomes a 1, 1 here becomes a 0, 0 here becomes a 1, 0 becomes a 1, 0 becomes a 1, 1 becomes a 0, 0 becomes a 1. And now we need to add 1. Okay, so 1 plus 1. And people get confused with this, as I've said before, so we're just adding these. You can ignore that other row now. So 1 plus 1 is 1, 0, so I'm going to carry a 1. 1 plus 1 is 1, 0, so I'm going to carry a 1. 0 plus 1 is 1, and there's nothing to carry now, so all of these just stay the same. Okay, so it passes a common sense test because it's a negative number, so the MSB has to be a 1, and 68 is an even number, so this needs to be a 0. And it's quite handy having these little checks. If you're under a time pressure, it can be really useful. So let's just add it up and see if it does give us a binary value of minus 68.
So we've got a 1 here, so that's minus 128, and we have a 0 here, so we don't add 64, but we have a 1 here, so we add 32. So minus 128 plus 32 is, well, 8 minus 2 is 6. Okay, so 12 minus 3 is 9, so we're at minus 196 now, and then we have a 1 here, so we need to add 16, so minus 96 add 16 is 80. Okay, we've got a 1 here, so we need to add 8, so that gives us minus 72, plus, we've got a 1 here, so we need to add 4, so minus 72, add 4 is minus 68.
Okay, so this is our figure, minus 68, which is what we were trying to get to with our 2's complement process. Can you now take this minus 68 expressed as a binary number and use arithmetic shifting, shifting twice to the right to divide that number by 4. Pause the video, have a go. Let's see what we get. Okay, so hopefully you got something like this. We drop vertically, which is what we've done here, and then we jump across 2 spaces, shifting right. So this 1 here is also here, and then this 0 goes here, and this 1 goes here, and this 1 goes here. You get the idea. Okay, and these 2 zeros here, they've just dropped off the end there. So what, I hear you ask, goes here? I'm sure you remember by now that when we need to fill a gap, we fill it with a 1 with arithmetic shifting. So this is our answer, and all that remains now is for us to reverse engineer that and just work out, make sure that we've got the right answer.
Okay, so we've got a 1 here, so we start at minus 128, and 1 here, add 64, 1 here, add 32, so we are now at minus 32. Now we've got a 0 here, so we don't add 16, but we've got a 1 here, so we do add 8. So minus 32 plus 8 is minus 24. And we've got a 1 here, so we add 4, so minus 24 plus 4 is minus 20, and we've got a 1 here, so we're adding a 2, so that takes us to minus 18, and minus 18 plus 1 takes us to minus
17. So this number here is minus 17. So, is this correct? Minus 68 divided by 4 equals minus 17. And that is indeed correct. So what we did with this last question was actually a really good way to revise, and I really recommend, you can really save time and speed things up if you get really familiar with this. So if you pick a negative denary number and then you convert it to a signed into a negative binary number using 2's complement, and remember to do that, you basically just work out the positive binary value, and then you flip all the bits. So if it's a 1, it's a 0, and then it's a 0, it's a 1, and then you add 1, and that will give you the negative binary value for that denary number. And then you can use arithmetic shifting to divide by 2 or divide by 4, or if you're feeling really brave, you could try and divide by 8. So have a go at doing a few of those to really embed it into your memory, and then in an exam situation you are so much quicker and it gives you time to do other exam questions. Okay, good luck.